Right now, across our planet, an extraordinary hunt is taking place in silence. Giant radio telescopes, these massive technological sentinels, are constantly scanning the depths of space, collecting mysterious signals from the cosmos. Among the billions of radio waves traveling through the vast expanse of space, there could be just one special signal that would forever change the course of human history, the definitive proof that we are not alone in the universe. From the remote deserts of Chile to the quiet mountains of Puerto Rico, teams of dedicated scientists work tirelessly, analyzing an endless stream of data from the stars. Every beep, every pattern, every unusual frequency could potentially be that groundbreaking message from an alien civilization. This isn't science fiction. This is the cutting-edge science of SETI, the search for extraterrestrial intelligence. In our journey today, we'll explore the fascinating world where science meets one of humanity's oldest questions. Are we alone in the cosmos? We'll dive deep into the incredible technology that allows us to listen to the stars, understand how scientists distinguish between natural cosmic phenomena and potential artificial signals, and discover the remarkable methods used to search for signs of intelligent life among the billions of stars in our galaxy. From the revolutionary advances in radio astronomy to the groundbreaking algorithms that help us decode the universe's mysterious messages, you're about to discover how modern scientists are conducting the greatest search in human history. This is where cutting-edge technology meets our timeless curiosity about the unknown. Before we reveal the secrets of this fascinating quest, don't forget to hit that subscribe button and turn on notifications for exploring the universe. Join our growing community of cosmic explorers as we embark on this extraordinary journey through space and time. Together, we'll explore the mysteries of the cosmos and maybe, just maybe, be part of the generation that makes the greatest discovery in human history. By subscribing to our channel, you'll ensure you don't miss any updates about potential breakthrough discoveries, fascinating space phenomena, and the latest developments in our search for cosmic companions. The universe is calling. Are you ready to answer? Let's dive into the fundamental principles of SETI, one of humanity's most ambitious scientific endeavors. The search for extraterrestrial intelligence, commonly known as SETI, began as a revolutionary idea in 1984 when the SETI Institute was established. However, its roots go back to 1959 when physicists Giuseppe Cocconi and Philip Morrison first suggested that radio waves could be used to communicate across interstellar distances. The choice of radio waves for this cosmic search isn't random. Radio waves represent an ideal medium for interstellar communication for several compelling reasons. First, they can travel enormous distances through space with minimal degradation, while visible light and other forms of electromagnetic radiation can be blocked by cosmic dust and gas. Radio waves pass through these obstacles relatively unimpeded. Additionally, radio waves are relatively easy and inexpensive to produce, making them a logical choice for any technological civilization attempting interstellar communication. The concept of the cosmic radio window is particularly fascinating. This refers to a specific range of radio frequencies between 1 and 10 gigahertz, where interstellar communication is most practical. Below this range, natural radio emissions from our galaxy create too much interference, while above it, the Earth's atmosphere becomes increasingly opaque. Within this window, there's a particularly interesting frequency near 1.420 gigahertz, the natural emission frequency of neutral hydrogen, the most abundant element in the universe. Many scientists theorize that any intelligent civilization would likely monitor this frequency, making it an ideal channel for first contact. The Drake equation, formulated by Frank Drake in 1961, provides a theoretical framework for estimating the number of communicating civilizations in our galaxy. While it may look intimidating at first, it can be broken down into simple components. The equation considers factors such as the rate of star formation, the fraction of stars with planetary systems, the fraction of planets that could support life, the probability of life actually developing on those planets, the probability of that life becoming intelligent, the probability of intelligent life developing communication technology, and how long such civilizations might last. Let's express it this way. Imagine you're trying to count all the people in a vast city who might want to talk to you. You'd need to know how many buildings there are, stars, how many have apartments, planets, how many apartments are habitable, suitable conditions for life, how many are actually occupied, where life exists, how many occupants speak your language, intelligent life, how many have phones, communication capability, and how long they typically stay there, civilization longevity. The Drake equation follows similar logic, but on a cosmic scale. Modern SETI research has evolved significantly from its early days. Today's projects utilize massive radio telescope arrays, sophisticated signal processing algorithms, and machine learning to sift through the enormous amount of data collected. The Allen Telescope Array in California, for instance, can monitor multiple star systems simultaneously, dramatically increasing the efficiency of the search. What makes this search particularly compelling is that we only need to be successful once. A single confirmed detection of an artificial signal from another civilization would answer one of humanity's most profound questions and fundamentally change our understanding of our place in the cosmos. This is why SETI continues to capture both scientific and public imagination, representing humanity's systematic attempt to reach out into the cosmic ocean and discover if anyone else is out there, sending their own messages across the vast expanses of space. Unlike many other scientific endeavors, SETI holds the unique position of potentially being able to answer one of humanity's oldest questions in a single moment of discovery. Whether that moment comes tomorrow or in 100 years, the search itself represents one of humanity's noblest scientific pursuits, the quest to understand our place in the cosmic community. The technology behind our search for extraterrestrial intelligence represents one of humanity's most sophisticated scientific endeavors. At its core, the detection process involves massive radio telescopes that act as cosmic ears, listening to the symphony of space while trying to identify any unusual patterns that might indicate artificial origin. The detection process begins with enormous radio telescopes, like the 100-meter Green Bank telescope in West Virginia or the 500-meter FAST telescope in China, collecting radio waves from specific target areas in space. These telescopes are engineering marvels, capable of detecting incredibly faint signals from thousands of light years away. Think of them as immense satellite dishes, but instead of receiving TV signals, they're capturing the faintest whispers from distant stars. When it comes to the types of signals we're looking for, scientists have developed specific criteria that might indicate artificial origin. One primary target is narrow-band signals, particularly those around 1.420 gigahertz, the hydrogen line. Natural sources typically produce broadband emissions, so finding a very narrow-band signal could suggest technological origin. We also look for regular patterns or pulses that appear to carry information, similar to how we encode our own radio and television broadcasts. The differentiation between natural and artificial signals is one of the most challenging aspects of SETI. Natural phenomena like pulsars, quasars, and even terrestrial sources can create signals that initially appear artificial. Scientists use sophisticated algorithms to filter out known natural sources and human-made interference. They look for specific characteristics that might indicate artificial origin, such as signals that appear to shift in frequency in a way that would compensate for Doppler effects. Something a technically advanced civilization might do intentionally to make their signal easier to detect. The Breakthrough Listen initiative, launched in 2015 with $100 million funding from Yuri Milner, represents the most comprehensive search for artificial signals ever undertaken. This project monitors over 1 million stars and 100 galaxies, using some of the world's most powerful telescopes. What makes Breakthrough Listen particularly impressive is its technological sophistication. It can process an enormous amount of data, equivalent to streaming every movie ever made, every second. Other current projects are equally fascinating. The SETI Institute's Allen Telescope Array in California can observe multiple targets simultaneously, dramatically increasing the efficiency of the search. The FAST telescope in China, the world's largest single-dish radio telescope, has recently joined the search, bringing unprecedented sensitivity to the effort. The Meerkat Array in South Africa offers yet another powerful tool, with its multiple linked telescopes providing extraordinary resolution. Machine learning and artificial intelligence have revolutionized how we process these astronomical amounts of data. Modern SETI projects use sophisticated AI algorithms to identify patterns that might be missed by traditional analysis methods. These systems can quickly sort through millions of signals, identifying those that warrant closer human examination. One particularly innovative approach is the search for technosignatures, signs of advanced technology rather than direct communication signals. This includes looking for unusual infrared emissions that might indicate waste heat from advanced civilizations, or searching for unusual chemical signatures in exoplanet atmospheres that might suggest industrial activity. Real-time signal analysis has become increasingly important. When an interesting signal is detected, multiple telescopes can be quickly coordinated to observe the same target, helping to verify if the signal is genuine or just interference. This network approach has dramatically reduced false positives and increased our ability to quickly follow up on promising signals. The future of SETI technology looks even more promising. Next-generation radio telescopes like the Square Kilometre Array being built in Australia and South Africa will provide unprecedented sensitivity and coverage. Quantum computing may soon offer new ways to process the massive amounts of data collected, potentially revealing patterns we've never been able to detect before. All these technological advances share a common goal: to sift through the cosmic static and find that one signal that would change everything. It's a search that combines the most advanced technology humanity has ever created with our most fundamental questions about our place in the universe. Throughout our decades-long search for extraterrestrial intelligence, several discoveries have captured the imagination of both scientists and the public. These mysterious signals and phenomena, while not yet providing definitive proof of alien life, have pushed the boundaries of our understanding and sparked intense scientific debate. The most famous of these enigmatic discoveries is undoubtedly the WOW signal detected on August 15, 1977, by Ohio State University's Big Ear radio telescope. The signal was so remarkable that astronomer Jerry Eman wrote "Wow" on the computer printout. What made this signal particularly intriguing was its characteristics. It appeared exactly in the frequency range scientists expected alien civilizations might use, lasted for 72 seconds, and never repeated. Even today, after more than 45 years, it remains one of SETI's most compelling mysteries. Tabby's star, officially known as KIC 8462852, presents another fascinating puzzle. Discovered through the Kepler Space Telescope data, this star exhibits unprecedented and inexplicable dimming patterns, sometimes losing up to 22% of its brightness. While natural explanations like dust clouds or comets have been proposed, none fully explain the star's bizarre behavior. Some scientists, including Harvard's Avi Loeb, have even suggested the possibility of artificial structures like alien megastructures, although this remains highly speculative. Oumuamua, our solar system's first confirmed interstellar visitor, made headlines in 2017. This cigar-shaped object displayed several peculiar characteristics that defied conventional explanation. It accelerated as it left our solar system, showed no visible comet tail despite this acceleration, and reflected sunlight in an unusual way. While most scientists favor natural explanations, the object's properties were unusual enough to prompt serious scientific discussion about artificial origins. Fast radio bursts represent one of modern astronomy's most perplexing phenomena. These incredibly powerful bursts of radio waves last only milliseconds, but release more energy than our sun does in decades. While natural explanations like magnetars are now favored, the regular patterns of some FRBs, particularly FRB 12102, which repeats in a predictable pattern, initially led to speculation about artificial origins. These events continue to push our understanding of extreme cosmic physics. The BLC-1 signal, detected in 2019 from the direction of Proxima Centauri, our nearest stellar neighbor, caused significant excitement in the SETI community. This narrowband signal persisted for several hours and appeared to shift in frequency exactly as would be expected for a signal coming from a planet orbiting Proxima Centauri. While later analysis revealed it to be human-made interference, the incident demonstrated both the sophistication of modern SETI techniques and the rigorous process used to verify potential signals. Each of these discoveries, while not providing definitive evidence of extraterrestrial intelligence, has contributed significantly to our scientific understanding and improved our search methods. They remind us that the universe is filled with phenomena we don't yet fully understand, and that the search for extraterrestrial intelligence is as much about expanding our scientific knowledge as it is about finding alien civilizations. Now here's an interesting thought experiment for you. If you could send one message to an alien civilization, what would you say? What would you want them to know about humanity? Share your thoughts in the comments below. Let's explore together how we might introduce ourselves to our cosmic neighbors. Don't forget to like this video and subscribe to our channel for more fascinating space mysteries and discoveries. These intriguing discoveries continue to remind us that the universe is far more mysterious and complex than we often imagine. While we haven't found definitive proof of extraterrestrial intelligence yet, each unusual signal and unexplained phenomenon pushes us to improve our detection methods and expand our understanding of the cosmos. When we delve into the fascinating world of SETI, we discover some truly remarkable protocols, theories, and historical attempts at cosmic communication that often surprise even seasoned space enthusiasts. Let's start with the first detection protocol, one of the most intriguing and carefully thought-out procedures in modern science. If a potential alien signal is detected, scientists can't simply announce it to the world immediately. Instead, they must follow a detailed international protocol. First, the signal must be independently verified by multiple observatories. Then, once confirmed, a careful sequence of notifications begins, from the International Astronomical Union to world governments and scientific institutions. This protocol exists to prevent false alarms and ensure that humanity responds to such a momentous discovery in a coordinated and responsible way. Humanity hasn't just been listening, we've been actively reaching out to the stars. Several messages have already been sent into space, starting with the famous Arecibo message in 1974. This binary transmission, aimed at the globular cluster M13, contained information about our number system, DNA structure, human figure, and our solar system. The cosmic call messages of 1999 and 2003 were sent to nearby stars, containing detailed information about Earth and human civilization. More recently, in 2017, the sonar calling GJ273b project sent music and scientific tutorials to a potentially habitable exoplanet. The travel time of these messages reveals the enormous scales involved in interstellar communication. The Arecibo message, for instance, won't reach its target for about 25,000 years. Even if we sent a message to our closest stellar neighbor, Proxima Centauri, it would take over 4 years to arrive. A potential reply would take another 4 years to reach us, meaning any interstellar conversation would span generations. The Fermi paradox, named after physicist Enrico Fermi, presents one of the most puzzling questions in SETI research. Fermi asked, "Where is everybody? Given the vast age of the universe and the billions of potentially habitable planets, why haven't we detected any signs of alien civilizations?" This apparent contradiction between the high probability of extraterrestrial civilizations existing and our lack of contact with them has spawned numerous theoretical explanations. One particularly fascinating solution to the Fermi paradox is the zoo hypothesis, or cosmic zoo theory. This suggests that alien civilizations might be deliberately avoiding contact with Earth, treating our planet like a wildlife preserve or zoo. According to this theory, advanced civilizations might have agreed to a non-interference policy, allowing humanity to develop naturally without external influence. Some proponents even suggest that mysterious UFO sightings could be explained as occasional monitoring of our exhibit. The implications of these ideas extend beyond mere scientific curiosity. For instance, scientists have debated whether we should actively send messages into space, known as messaging extraterrestrial intelligence, or simply listen. Some, like Stephen Hawking, warned against broadcasting our presence, comparing it to Native Americans' first contact with Europeans. Others argue that any civilization advanced enough for interstellar travel would already know we're here through our radio and television broadcasts, which have been leaking into space for nearly a century. These broadcasts, known as our radio bubble, extend roughly 100 light-years into space, containing everything from early television shows to modern digital communications. This means that any alien civilizations within this sphere could potentially be watching I Love Lucy reruns or picking up signals from our early military radar systems. Our efforts to contact potential alien civilizations have also led to innovative communication methods. Scientists have considered using binary code, mathematics, prime numbers, and even music as universal languages. The Voyager Golden Records, launched in 1977 on the Voyager spacecraft, contain sounds, images, and music from Earth, a time capsule of humanity designed to be understandable by any intelligent civilization that might find them. The development of these communication attempts has forced us to think deeply about how to convey meaning across potentially vast cultural and biological differences. How do you explain human concepts to beings that might perceive reality in fundamentally different ways? This challenge has led to fascinating developments in linguistics, mathematics, and information theory. The existence of these protocols, theories, and communication attempts reveals something profound about humanity. Even as we search for signs of extraterrestrial intelligence, we're also preparing for what might happen if we find it. Whether through carefully planned response protocols or thoughtfully designed messages, we're attempting to lay the groundwork for what could be the most significant encounter in human history. The search for extraterrestrial intelligence faces several formidable challenges and limitations that make it one of humanity's most ambitious scientific endeavors. Understanding these challenges helps us appreciate both the complexity of the search and the ingenuity required to overcome them. The sheer vastness of space presents our first and most fundamental challenge. Our Milky Way galaxy alone contains over 100 billion stars, and it's just one of billions of galaxies in the observable universe. To put this scale in perspective, if we spent just 1 second examining each star in our galaxy, it would take over 3,000 years to complete the survey. Even with our most powerful telescopes, we can only observe a tiny fraction of potential targets at any given time. The three-dimensional nature of space means that signals could come from any direction, at any time, making comprehensive surveillance nearly impossible. Communication delay represents another significant hurdle. Even at the speed of light, the fastest speed possible according to our understanding of physics, signals take considerable time to travel interstellar distances. The nearest star system, Alpha Centauri, is about 4137 light-years away. This means that even if we detected a signal from a civilization there and responded immediately, the total conversation time would be nearly 9 years for just one exchange. For more distant stars, the delay could span centuries or millennia. This poses profound questions about the practicality of interstellar communication and the nature of any potential dialogue. Terrestrial interference has become an increasingly serious problem for SETI research. Our modern civilization generates an enormous amount of radio noise. Cell phones, satellites, radio stations, military radar, and countless other electronic devices create a constant background of artificial signals that must be filtered out. This challenge has become so significant that many radio telescopes must be located in remote radio quiet zones, where electronic devices are strictly limited. Even then, distinguishing between human-made signals and potential extraterrestrial ones requires sophisticated filtering techniques. The technological limitations we face are equally daunting. Despite our remarkable scientific progress, our current technology can only detect very powerful signals from distant stars. To put this in perspective, even our strongest radio transmissions would be virtually undetectable by an identical civilization just a few light-years away using technology similar to ours. We face limitations in computing power. Processing the enormous amount of data collected by radio telescopes requires massive computing resources. Even with modern supercomputers and distributed computing projects like SETI at home, we can only analyze a fraction of the data in real time. Signal detection. Our instruments are limited in their sensitivity and the range of frequencies they can monitor simultaneously. While we focus primarily on radio waves, alien civilizations might use communication methods we haven't even discovered yet. Energy constraints. Monitoring multiple targets continuously requires significant power and resources. The operation of large radio telescopes is expensive, and funding for SETI projects is often limited. Time synchronization. We might be looking in the right place, but at the wrong time. An alien civilization could have existed millions of years ago and vanished, or might not yet have developed. This synchronicity problem adds another layer of complexity to the search, resolution and coverage. Even our most advanced telescopes have limitations in their ability to resolve distant objects and cover large areas of the sky. The upcoming square-kilometer array will improve our capabilities, but we'll still be limited in our ability to conduct comprehensive surveys. These challenges are compounded by our uncertainty about what exactly we're looking for. We base our search strategies on our own technological development and understanding of physics, but alien civilizations might use completely different technologies or communication methods that we can't even conceive of yet. However, these limitations don't make the search futile. They make it more fascinating. Each challenge has spurred technological innovations and new approaches to detection. The development of AI and machine learning algorithms helps us better process vast amounts of data. New telescope arrays and detection methods are constantly being developed. Multi-wavelength observation strategies help us overcome some limitations of traditional radio astronomy. Understanding these challenges is crucial because it helps us develop more effective search strategies and set realistic expectations. While the task is daunting, each technological advance brings us closer to potentially answering one of humanity's most profound questions. Are we alone in the universe? The search for extraterrestrial intelligence has been shaped by several visionary scientists whose insights and perspectives have profoundly influenced our approach to this cosmic quest. Their diverse viewpoints offer a rich tapestry of thought about one of humanity's most profound endeavors. Carl Sagan, perhaps the most eloquent ambassador of space science to the public, viewed SETI as a fundamental expression of human curiosity and hope. In his influential works, including Contact and Cosmos, Sagan argued that the search for extraterrestrial intelligence was not just a scientific endeavor, but a deeply human one. He famously stated, "The universe is not required to make sense to you," but he believed that our attempt to understand it through SETI revealed something profound about our species. Sagan emphasized that even if we never find extraterrestrial intelligence, the search itself advances our technology, our understanding of the cosmos, and our perspective on our own civilization. Jill Tarter, often considered the real-life inspiration for the protagonist in Contact, has dedicated her entire career to SETI. Her perspective is particularly compelling because it evolved through decades of hands-on research. Tarter often emphasizes that SETI is not about finding alien civilizations. It's about asking the right questions and developing the right tools to detect techno-signatures. She powerfully articulated that we are what happens when a primate's brain is marinated in cosmic rays for about 4 billion years. Her work has been instrumental in transforming SETI from a fringe scientific pursuit into a respected field of research. Frank Drake's legacy extends far beyond the famous equation that bears his name. As the pioneer of modern SETI research, Drake conducted the first modern SETI experiment, Project Ozma, in 1960. His approach to the search was methodical and scientific, establishing protocols that are still used today. Drake consistently argued that SETI should be viewed as a long-term scientific endeavor, not a quick search for immediate results. He often said, "The probability of success is difficult to estimate, but if we never search, the chance of success is zero." Avi Loeb's controversial perspectives on Oumuamua have sparked intense scientific debate and public interest. As chair of Harvard's Astronomy department, Loeb took the bold step of suggesting that Oumuamua's unusual characteristics warranted considering artificial origins. His argument wasn't that Oumuamua was definitely artificial, but rather that we should be open to considering all possibilities when confronted with anomalous data. In his book, Extraterrestrial, Loeb argues that the scientific community is often too conservative in considering the possibility of artificial origins for unusual phenomena. He advocates for what he calls cosmic modesty, the idea that we shouldn't assume we're particularly special or alone in the universe. Today's SETI researchers build upon these perspectives while incorporating new technologies and methodologies. The field continues to evolve, with new voices adding their insights to this ongoing dialogue about one of humanity's most profound questions. Modern experts increasingly emphasize the need for multidisciplinary approaches, combining traditional radio astronomy with the search for technosignatures, biosignatures, and other potential indicators of extraterrestrial intelligence. They also stress the importance of developing new detection methods and expanding our concept of what alien technology might look like. These varying expert perspectives remind us that SETI is not just a search for signals from the stars. It's an endeavor that pushes the boundaries of our scientific capabilities while forcing us to confront fundamental questions about our place in the cosmos. Recent advances in our search for extraterrestrial intelligence have revolutionized how we scan the cosmos, process data, and understand potential signs of alien civilizations. These developments have dramatically expanded our capabilities and opened new avenues for exploration. The integration of machine learning and artificial intelligence into SETI research represents one of the most significant recent advances. Modern AI algorithms can analyze astronomical data with unprecedented speed and accuracy, detecting patterns that might escape human observation. For instance, the Breakthrough Listen initiative now employs deep learning networks that can distinguish between human-made radio interference and potential alien signals. These systems can process millions of signal candidates in seconds, dramatically increasing our search efficiency. These ML systems are particularly adept at identifying fast radio bursts, FRBs, and other transient phenomena that might otherwise be missed. They've been trained on massive data sets of known astronomical signals and can identify anomalies that don't match any known natural phenomena. Some cutting-edge projects are even using adversarial neural networks to predict what artificial signals might look like based on our own technological development. The landscape of radio astronomy has been transformed by new telescopes and arrays. The China Sky Eye, the world's largest single-dish radio telescope, began SETI observations in 2020, offering unprecedented sensitivity to weak signals. The Meerkat Array in South Africa provides remarkable resolution with its 64 linked dishes, while the upcoming Square-Kilometre Array promises to revolutionize our observational capabilities. These new facilities aren't just bigger, they're smarter. Modern telescopes use adaptive optics, real-time signal processing, and advanced interference mitigation systems. The Allen Telescope Array, specifically designed for SETI, can observe multiple targets simultaneously, dramatically increasing search efficiency. The explosion in exoplanet discoveries has transformed our understanding of potential extraterrestrial habitats. The TESS mission alone has identified thousands of candidate planets, many in the habitable zone where liquid water could exist. This wealth of new targets has allowed SETI researchers to prioritize their searches, focusing on star systems most likely to harbor technological civilizations. Particularly exciting are discoveries of Earth-like planets around nearby stars, such as Proxima Centauri b and the TRAPPIST-1 system. These findings have led to targeted SETI observations of these promising candidates, using our most sensitive instruments to listen for any signs of technological activity. The field of technosignatures, signs of technological activity, has expanded dramatically beyond traditional radio signals. Modern SETI researchers now look for optical signatures, laser signals that might be used for communication or propulsion systems, infrared excess, waste heat from advanced civilizations, atmospheric technosignatures, industrial pollution or artificial atmospheric modifications, megastructures, artificial constructions that might be visible in stellar light curves, quantum communications, theoretical quantum-based communication systems. New detection methods have emerged as our understanding of technology evolves. For instance, researchers now search for signs of stellar engineering, artificial satellites around other stars, and even evidence of advanced propulsion systems. The search for industrial pollution in exoplanet atmospheres represents a particularly innovative approach, as certain chemical signatures could indicate technological activity. These advances have also led to more sophisticated search strategies. Instead of just listening for deliberate messages, modern SETI projects search for leaked technology signatures, the kind of technological footprints that our own civilization leaves in space. This includes looking for radar systems, power generation facilities, and space-based infrastructure. The integration of different observation methods has become increasingly important. Modern SETI projects often combine radio, optical, and infrared observations to build a more complete picture of potential technological activity. This multi-wavelength approach significantly increases our chances of detecting alien civilizations, regardless of their chosen communication methods. Data sharing and processing have also evolved dramatically. Cloud computing and distributed networks allow researchers worldwide to collaborate on data analysis. The public can even participate through citizen science projects that help process the massive amounts of data generated by modern telescopes. These recent advances have not only expanded our search capabilities, but have also made the search for extraterrestrial intelligence more rigorous and systematic than ever before. As our technology continues to evolve, new methods and approaches will undoubtedly emerge, further increasing our chances of detecting signs of extraterrestrial civilizations. Most importantly, these advances remind us that SETI is not a static field, but a dynamic, evolving scientific endeavor that continues to push the boundaries of human knowledge and technological capability. Each new development brings us closer to potentially answering one of humanity's most profound questions. Are we alone in the universe? The future of SETI research stands at an exciting crossroads, with groundbreaking technologies and innovative approaches poised to revolutionize our search for extraterrestrial intelligence. The James Webb Space Telescope represents one of the most significant advances in our ability to detect potential biosignatures on distant worlds. This remarkable instrument can analyze the atmospheres of exoplanets with unprecedented precision, looking for chemical signatures that could indicate the presence of life or even industrial activity. The JWST's ability to detect molecules like methane, oxygen and carbon dioxide in exoplanet atmospheres opens up new possibilities for identifying potential technosignatures. For instance, the presence of industrial pollutants or unexpected atmospheric compositions could suggest the existence of technological civilizations. The telescope's infrared capabilities also allow it to search for heat signatures that might indicate advanced energy use or artificial structures. The next generation of radio telescopes promises to dramatically expand our SETI capabilities. The Square-Kilometre Array, currently under construction in South Africa and Australia, will be the world's largest radio telescope when completed. With unprecedented sensitivity and the ability to survey vast portions of the sky simultaneously, the SKA will be able to detect much weaker signals from much greater distances than current instruments. This means we'll be able to search a much larger volume of space for potential alien transmissions. The next generation, Very Large Array, represents another leap forward in radio astronomy. This planned facility will provide 10 times the sensitivity of current arrays and operate across a broader range of frequencies. This capability will be crucial for detecting subtle technosignatures and distinguishing between natural and artificial signals. Artificial intelligence and machine learning continue to evolve rapidly, promising revolutionary advances in signal processing and data analysis. Future AI systems will be able to identify patterns and anomalies that human observers might miss, processing vast amounts of astronomical data in real time. These systems will become increasingly sophisticated at filtering out terrestrial interference and identifying potential alien signals. Quantum computing represents another frontier that could transform SETI research. As quantum computers become more powerful, they could help us decode complex signals and process astronomical amounts of data in ways that classical computers cannot. This could lead to entirely new methods of searching for and analyzing potential alien communications. Several ambitious projects are currently in development that could reshape our approach to SETI. The Breakthrough Starshot initiative, while primarily focused on interstellar exploration, could provide new platforms for detecting technosignatures. Its planned network of small spacecraft could potentially serve as a distributed array for detecting signals from deep space. The PanaSETI project represents a new approach to optical SETI, searching for artificial light signals across the entire visible sky. This project could detect brief laser pulses or other optical signals that might be used for interstellar communication. Looking further ahead, researchers are developing new methods to detect quantum communications, gravitational waves, and other exotic forms of signaling that advanced civilizations might use. The field of shadow biospheres, the search for life forms based on different biochemistry than Earth life, could also provide new insights into how we search for extraterrestrial intelligence. International collaboration in SETI research is expected to increase, with new facilities being built worldwide and data sharing becoming more sophisticated. The establishment of the SETI Post-Detection Hub at the University of St. Andrews represents a growing recognition of the need to prepare for the possibility of detection. Perhaps most excitingly, advances in exoplanet research will continue to identify promising target systems for SETI observations. As our understanding of planetary formation and habitability improves, we'll be able to focus our search more effectively on systems most likely to harbor technological civilizations. These future developments suggest that we're entering a golden age of SETI research, where multiple approaches and technologies will work in concert to conduct the most comprehensive search for extraterrestrial intelligence in human history. While success is never guaranteed, our ability to detect signs of alien civilizations will be greater than ever before, bringing us closer to potentially answering one of humanity's most profound questions. Are we alone in the universe? Let me guide you through some thought-provoking, interactive segments that will help us better understand the implications and complexities of SETI research. First, let's take a moment for reflection. What if we received a confirmed alien signal today? Imagine yourself going about your daily routine when suddenly every news outlet in the world interrupts their programming with this historic announcement. How would our world change in the first 24 hours? Scientists estimate several immediate impacts. Financial markets would likely experience significant volatility as humanity processes the implications. Religious institutions would begin the complex process of incorporating this new reality into their worldviews. Social media would explode with discussions, theories, and reactions. Governments worldwide would convene emergency sessions to discuss response protocols. But the real changes would be more personal and profound. Looking up at the night sky would never feel the same again. Every human on Earth would share a moment of realization that we are not alone in the cosmos. Our entire perspective on our place in the universe would shift fundamentally and irreversibly. Here's another interactive thought experiment. The communication challenge. Imagine you're tasked with designing a message to send to an alien civilization. You can only include 5 pieces of information about humanity. What would you choose? Consider our location in the galaxy, our biological makeup, our mathematical understanding, our cultural achievements, our technological level, our history. Share your choices in the comment section below, and let's discuss why these particular pieces of information might be most valuable for interstellar communication. The cultural impact of humanity's search for extraterrestrial life has shaped our perspectives and aspirations for generations, often serving as a mirror to our societal values and beliefs. The idea that we are not alone in the universe has influenced art, literature, and philosophy, fostering a collective curiosity that transcends borders. The discovery of extraterrestrial intelligence would be a paradigm-shifting event, challenging our understanding of identity, morality, and purpose. How would religions interpret this revelation? Would nations unite to engage with a newfound cosmic neighbor? These are questions that illuminate the profound cultural transformation such a discovery would catalyze. Society would undergo profound changes if alien life were confirmed. This revelation would likely lead to unprecedented collaboration as nations and institutions navigate the implications. Economically, industries like technology, defense, and communication would experience rapid innovation driven by attempts to understand and interact with alien intelligence. Socially, It would provoke widespread reflection on human commonalities, as the realization of an external observer forces us to re-evaluate divisions within our species. It would also inspire scientific and educational reform, emphasizing interdisciplinary studies to address the complex challenges posed by interstellar communication and cooperation. The preparation for first contact involves meticulous scientific and diplomatic planning. Protocols already exist under the SETI Post-Detection Task Group, outlining steps to verify and analyze signals, ensure transparency, and engage the global community responsibly. These preparations are not just technical, but also psychological, addressing how humanity might cope with the existential implications of such an encounter. Education campaigns would aim to reduce fear and misinformation, fostering a mindset of curiosity and respect toward extraterrestrial civilizations. International protocols play a critical role in ensuring a coherent response to first contact. The Rio scale assesses the significance of potential discoveries, guiding global reactions. Organizations like the United Nations could establish dedicated committees to oversee diplomatic interactions, ensuring that humanity speaks with a unified voice. Coordination among nations would be vital to prevent unilateral actions that might jeopardize peaceful relations. By focusing on inclusivity, equity, and shared responsibility, these protocols aim to present humanity as a species capable of collaboration and mutual respect. The true climax of SETI's mission is not merely the hope of finding extraterrestrial life, but the profound revelations we uncover about ourselves along the way. The search, at its core, is a mirror reflecting humanity's deepest questions. Who are we? What is our purpose? Are we truly unique, or are we part of a vast cosmic tapestry? As we scan the heavens for signs of life, we inadvertently explore the intricacies of our own existence, values, and aspirations. SETI becomes not just a pursuit of the unknown, but a journey of self-discovery, uniting science, philosophy, and culture in a shared quest to understand our place in the universe. Through this journey, we have already gained a treasure trove of knowledge. The meticulous study of the cosmos has advanced our technology, from the development of sophisticated radio telescopes to the application of artificial intelligence in data analysis. These innovations have ripple effects, improving everyday life on Earth, from medical imaging to communication networks. SETI exemplifies how the pursuit of distant horizons can generate practical advancements, showcasing humanity's ingenuity and resourcefulness. It highlights our ability to transcend immediate concerns to focus on something far greater, something that connects us all. More than technology, the greatest treasure lies in the philosophical and cultural shifts that SETI inspires. As we consider the possibility of intelligent life beyond Earth, we are forced to confront our biases, limitations, and preconceptions. What would it mean to encounter a civilization that evolved under entirely different conditions? Would we recognize their intelligence or overlook it due to our anthropocentric lens? These questions challenge us to expand our understanding of consciousness and redefine the parameters of life itself. They remind us that the universe is not tailored to human expectations, and that our ability to adapt intellectually and emotionally is a hallmark of our resilience. SETI also fosters a profound sense of unity. The search for extraterrestrial intelligence transcends borders, ideologies, and cultures, creating a global effort rooted in curiosity and collaboration. Every nation, every individual, has a stake in this quest. The prospect of finding intelligent life reminds us of our shared humanity, our collective fragility, and our common destiny as inhabitants of a single, small planet. It emphasizes that, in the grand cosmic scale, our differences are insignificant compared to what unites us, the unyielding drive to explore and understand. Even if SETI never detects an alien signal, the search itself is a victory. It exemplifies the human spirit's insatiable curiosity and relentless pursuit of knowledge. Every signal analyzed, every algorithm developed, every star system examined brings us closer to understanding the cosmos and, by extension, ourselves. It teaches us patience, humility, and perseverance, qualities that define our greatest achievements. In this way, the process of searching becomes as valuable as any discovery, proving that the journey often matters more than the destination. Ultimately, SETI's greatest revelation may not come from a distant civilization, but from the introspection it provokes in humanity. It urges us to think beyond our immediate concerns, to ask the biggest questions, and to embrace the unknown with courage and hope. The treasure we uncover is not just in the stars, but in the lessons we learn about cooperation, curiosity, and the boundless potential of the human spirit. In the end, SETI is as much about finding our place in the universe as it is about shaping a more unified, enlightened humanity. The stars, silent or not, inspire us to become better stewards of our world and seekers of the unknown. The search for extraterrestrial life transcends the boundaries of science and ventures into the realm of self-discovery. At its core, this quest is a profound reflection of humanity's innate curiosity and resilience. As we analyze every faint signal, every puzzling anomaly, we are reminded of our humble place in the vastness of the cosmos. We are but a small, fragile species on a tiny blue planet, orbiting an average star in an unremarkable corner of the Milky Way. Yet, within this insignificance lies something extraordinary: our capacity to wonder, to dream, and to question our very existence. The act of searching the stars reveals more about us than we may ever uncover about alien civilizations. It is a testament to our ability to transcend the boundaries of our knowledge, driven by the hope that beyond the vast expanse there might be others like us. Each step in this journey challenges us to confront the unknown with courage and humility. The silence of the cosmos is not disheartening. It is a call to introspection, urging us to re-evaluate our priorities as a species. It teaches us that while we search for others, we must also learn to better understand and care for ourselves and our planet. The search for extraterrestrial life is, in essence, a reminder of what makes us human: our boundless curiosity, our tenacity in the face of uncertainty, and our unshakable belief in the possibility of connection. The stars, whether silent or brimming with life, reflect our shared desire to belong, to find purpose, and to seek meaning in the infinite. As we conclude this cosmic journey today, let's reflect on the sheer wonder of being alive in an era where such questions can even be asked. Let's cherish the privilege of looking up at the night sky and daring to dream. Because in our pursuit of extraterrestrial intelligence, we are not just reaching out to the stars, we are reaching into the depths of our own potential, exploring the infinite possibilities of what it means to be human. And this journey doesn't end here. For those who share this unquenchable thirst for exploration, for those who look to the skies and wonder about the unknown, there is a place for you. To stay connected and continue this extraordinary quest, subscribe to our channel, Exploring the Universe. Hit the notification bell to ensure you never miss an update, a discovery, or an idea that might forever alter your perception of the cosmos. Share this video with fellow explorers, the curious minds who, like you, dare to ask the biggest questions. Together, we can embark on this journey, uncovering the mysteries of the universe, one star, one signal, and one question at a time. The cosmos awaits. Are you ready to explore it with us?